Physics is the study of how the world moves and interacts. In this deep dive, we will connect motion, forces, momentum, and energy, starting with the simplest question. What does it mean for something to move? First, separate two ideas that sound similar. Distance is the total length of the path traveled, so it has magnitude only. Displacement is the final position minus the initial position, so it includes both magnitude and direction. Distance is a scalar, displacement is a vector. Zephyr. Here is the classic example. A person walks 8 meters east, then 3 meters west. The total distance is 11 meters because both path segments count, but the net displacement is positive 5 meters. Final position 5 minus initial position 0. Direction makes the difference. Zephyr. Next, speed tells us how fast an object moves, while velocity tells us how fast and in which direction. A train moving at 45 meters per second describes speed. A train moving at 30 meters per second west describes velocity. Velocity can be positive or negative. Speed is always positive. For constant motion, the key relationship is distance equals speed times time. D equals V times t. Rearranging gives speed as distance divided by time. If an object travels 1,000 meters at 50 meters per second, the time is 1,000 divided by 50, exactly 20 seconds. The formulas look alike, but their meanings differ. Average speed is total distance divided by total time. Average velocity is displacement divided by total time. For a trip of 12 meters east and 20 meters west in 4 seconds, average speed is 32 divided by 4, or 8 meters per second. Average velocity is negative 8 divided by 4, or negative 2 meters per second. Zephyr. Acceleration measures how quickly velocity changes. It is change in velocity divided by change in time. It does not simply mean going fast. An object can move quickly with zero acceleration if its velocity stays constant. Acceleration appears whenever speed changes, direction changes, or both. Zephyr. Compare two vehicles reaching 60 miles per hour. A truck taking 30 seconds accelerates at 2 miles per hour per second. A sports car taking 5 seconds accelerates at 12 miles per hour per second. Both reach the same speed, but the sports car changes velocity much faster. Zephyr. A useful shortcut is to compare the signs of velocity and acceleration. When they have the same sign, the object speeds up. When they have opposite signs, it slows down. For example, a positive velocity with negative acceleration slows until it may stop, reverse direction, and then speed up in the negative direction. Near Earth's surface, gravity produces a downward acceleration of about 9.8 meters per second squared. That means a freely falling object gains about 9.8 meters per second of downward velocity every second, ignoring air resistance. Gravity is the reason falling motion is accelerated rather than constant. Newton's first law is the law of inertia. An object at rest remains at rest, and an object in motion continues with constant velocity unless a net external force acts on it. Things do not naturally stop moving. Friction, air resistance, or another force changes their motion. Newton's second law explains the size of a motion change. Force equals mass times acceleration, or F equals ma. More net force produces more acceleration. For the same force, a larger mass accelerates less. This relationship lets us connect a push or pull to a measurable change in velocity. Zephyr. Newton's third law says that forces come in pairs. When one object exerts a force on another, the second exerts an equal force in the opposite direction on the first. The forces do not cancel because they act on different objects. Skaters pushing apart are a clear example. Zephyr. Momentum combines mass and velocity. P equals m times v. A fast object has momentum, and a more massive object moving at the same speed has even more. Momentum is especially useful for understanding collisions because interactions transfer momentum between objects, while the total momentum of a closed system is conserved. Zephyr. Projectile motion combines two independent motions. Horizontally, the object moves at constant velocity when air resistance is ignored. Vertically, gravity accelerates it downward. Together, those motions create a curved, parabolic path. A thrown ball, a kicked soccer ball, and a launched rocket all reveal this same pattern. Zephyr is another powerful lens for motion. At a high point, an object can store gravitational potential energy. As it falls, that potential energy converts into kinetic energy, the energy of motion. In an ideal system, energy changes form rather than disappearing, though friction can transfer some into heat and sound. Zephyr. When facing a physics problem, begin with 4 questions. What object is moving? Which direction counts as positive? What forces act on it? And what is changing? Position, velocity, momentum, or energy? This habit turns a complicated situation into a set of clear relationships you can analyze.